Okay, okay, dokie. Let's get down to your lecture. Now, to open that out. Now, trusting you can all see that clearly.
Yeah,
Good, good.
yeah.
We're off to a flying start. Anyway, tonight, heavy going stuff. Not really. We've covered many of the aspects of tonight, but we just want to delve down into some of the technical stuff. Um, and what I might do is I might give you the notes I work off, my own lecture notes. We'll see. I will be uploading a couple of documents. The G company that I couldn't think of wasn't Gallup, it was Gartner. They are technology, IT analysts, and they're often on the likes of Bloomberg and that, and they generate reports on technology across all industry sectors. PwC would be another one up there, KPMG also up there. They're more generic, but Gartner and Quadrant is another crowd that kind of focus more onto the uh, retail food sector, but the one that I deal with is Gartner, and they produce reports, and sometimes we're privileged to get some of those reports, um, not at full market price. You can pay 10, 20, 30,000 dollars for a full Gartner report, because they pull across, they do pure research, literally pulling information from hundreds, if not thousands, of companies, and the right people in those companies, and that's how they assimilate, and that's how they're able to make these predictions. And one of the documents that I will upload to Moodle for your own perusal talks about a couple of predictions, some that they got right and some that they didn't get so right. But they're a great source, and sometimes they facilitate downloading of white papers. And if you're working in this space in particular, in supply chain, there are a number of such sites that you can get some really valuable information, and it'll just give you an idea of the breadth and depth of supply chain and where it's going. And so hopefully some of this material tonight will possibly inspire you to change careers, maybe, I don't know, focus or how to say, specialize in a particular area if you're already in supply chain. So let's get the show on the road. I'm looking at technology and managing information in supply chains, and you've heard me talk about it so many times. I know Colin will slag me off again when I mention EDI again, and as I've mentioned so many times,
Just showing your age.
I'm showing my age is right. Um, I, I've been in businesses before computers. That's how long, how far, which I'll have to say has been a blessing in disguise, because we've had to learn the nuts and bolts and bring it from absolute basics, literally programming the machines ourselves, to actually using your touch screens and all this sort of stuff to which we have today. But apart from all that historic stuff and prehistoric stuff, um, where we are today. So what we're going to fly through tonight, and I don't envisage keeping you the full 2.5 hours. I'll just go head on into it and get through the stuff and call it quits at whatever time I finish at. Um, so really, we need to focus on these key areas in when we look at supply chains, and I like this particular topic or side of it because it forces you to stand back and get your heads out of the dungeons of supply chain. If you're in, for example, doing a specific role inside an organization, it gets you out and get your heads up into the clouds to see what actually can happen, or where things are in relation to supply chains and how important they are. I mean, I was reading one article, you probably came across it today, that splashed up on news. Well, maybe not, but it was one particular ship, container ship, is jammed in the Suez Canal, and there are ships backed up on both sides of the Suez Canal, It's probably running into 50, 60, possibly 100 ships on either side now at this stage. It was, I have no idea how it happened. They hadn't freed it. I've been watching it all day to see if there's any movement on this. But it just goes to show a simple error like this. Now, these are all sat nav
The wind
guided.
blew it sideways, apparently.
The wind,
Allegedly.
allegedly, it would make sense given the height of the containers that were on it, and it's just jammed now. You would think that a couple of ropes on either side and a few JCBs would pull it apart or pull it, but it's not solving the problem. But in the context of supply chain and technologies and what we're looking at, all that vital information now showing potential delays across a whole range of industries and supply chains, all because of that. Can they make it up? Time? I don't know. We're running into hours now and nearly a day, and that's a lot of fuel. So it comes at a cost if ships are trying to put the boot down and catch up on lost time. Don't see it happening. I don't think it's free jet anyway. But that's the kind of thing, as Colin was saying, apparently the wind, which can only be the only sensible thing that could cause something like that to happen. How it happened this time, God only knows, given the complexity of the systems that they're using on those ships, and not to be able to have taken corrective action. So anyway, let's start jumping down through these. I am recording, yeah. Information requirements, systems capabilities, supply chain management software itself, and then of course the technology selection, and finally some of the innovations. Now, I've augmented these slides slightly towards the very end, but don't panic about them, because at least it'll be on the video. So if we start to look at information requirements, and it's a nice little diagram here where it begins to show the relevant information that if you look at the complete system, supplier information, service information, and all the support elements for your supply chain as the complete system outside here, and then inside here, timely info, accessible info, relevant information, and of course accurate information. These are, and they may sound pretty basic, and you would assume, but you know what they say about assume, that these are straightforward. By no means, because of the fundamentally legacy systems, bespoke systems, piecemeal patchwork quilt systems that have been put together inside in companies over years, and so on, and not having the right investments, and not being able to identify or evaluate the return on investments on upgrading systems. So that brings me into kind of one of my hobby areas, which would be project management and systems and implementing systems and so on, and future-proofing systems. Often a problem that or an aspect or a perspective that's overlooked and fundamentally causes problems. But we'll come to that later on. So you have these four key areas that you're trying to cover: operations, the logistics itself, customer servicing, and purchasing. So we essentially try to link all of these, providing information. So it's like a layer, an invisible layer on top of the physical things that we actually do, and that's an important point. And I'll show you, there's one particular slide that really pins it all, coming up in a while. But we have, when we look at these principles for the information requirements, you must have, the system must meet quality standards. Now this is above and beyond the products and services themselves. You must have multi-directional flows of information. So systems need to be able to talk to one another, and then provide decision support. And that's the kernel of this, the type of information or the type of data that's gathered to provide information for decision-making purposes. Okay, now most current systems today allow you to interact in real time when things are happening. And they kind of fall under, generically, I mentioned them last week, or possibly the week before, Saturday, control tower systems. And there are essentially two types of control towers. And I know one or two people probably wondered, well, more than one or two, what in the name of God is he talking about? And I use this concept of like an air traffic control tower. Essentially, that's what it is, but it's software. It's a cloud-based type system. Okay, there are numbers of them out there that you can use, but they're highly integrated systems, pulling all your all the different systems across the supply chain together, so they can actually monitor. It's like having dials on all of the different parts of the supply chain and all the different versions or users of the SAPs, the CRMs, and MRPs and so on in each company, and the linkages between fundamentally the transport systems and the operation systems. So these cloud-based systems are just another layer, but they're capturing data. Now you have fundamentally two types of control tower systems. You have the transactional and analytical, and oftentimes you can get how to say awestruck by the analytical type system. They serve their purposes, but really what you need to be looking at are the transactional, the real-time systems, because the analytical ones are just pulling data and say, right, we have all this, now so what? You can't really interact with them. You're pulling the data and you're making decisions retrospectively. Whereas with the transactional type control tower systems, you're in real time. So if something is going wrong, such as that ship going sideways, what can we do now? We need to make decisions. Do we need to send more ships? Do we need to alert different suppliers to supply through planes, get the products over to us quickly, and so you can make these real time interventions in transactional type control tower systems. So moving on. You have to have, as I said, provide decision support, and that's more of the transactional type. And as I said here, support multi-directional flows, multi-directional across all the different parts of the supply chain. And that brings into itself, some of its own complexity. So let's look at some of these individually. The quality standards, and these are fundamental for any system you're putting into an organization. Accuracy, accessibility, relevance, timeliness, transferability, usability, and reliability of the data or the information. Now, again, bear in mind that all of this is structured. What I mean by that is everything collected is data, just ones and zeros. And based on that data, it's overwhelming. We can't understand it, obviously. And even if we, bring it up to the next level and go to hexadecimal type of code, then we can begin to read some of that. But for the majority of people, no. We need to be able to put it into some kind of higher level language, such as English. So it's still only data. We then need to be able to aggregate the data, pull it together. For example, the number of items in stock by the number of divided by the number of days gives you your turnaround. Now you have two pieces of data. Now you have information, because it gives you, so any kind of a ratio, for example, or formula gives you an output, which is information. When we act on that information, we generate knowledge, and that's the hierarchy of things that we know. We have data, which is information. We act on the information, that becomes knowledge, and over time we get experience, so it begins to close the loop again. So we start to look at different types of data and so on, and then we start to future proof and say, what data do we not have, and can we now extrapolate what we have, what we don't have, from what we already have, and interact it and make decisions in advance. Now you're into machine learning territory, artificial intelligence territory. So it's taking the human side out of it and enabling us to become more efficient about the decisions we want to make and the knowledge we're trying to develop. That's why I mentioned earlier on, there's so many facets to supply chain in terms of specialization and expertise, and you can go into any one of dozens of different careers within this. Software development, for example. But we look at the second criteria here of our requirement, multi-directional flows, and this is pretty straightforward. You have to deal with multiples of suppliers Just think of Musgraves and the hundreds or couple of thousand suppliers that they'll have, both on and off the island of Ireland, just to be able to coordinate all their deliveries into the main distribution centres. Logistics service providers themselves, transportation, so TMSs, these transportation management systems, have again all enabled with GPS and mobile data. That's essentially the core technology to underpin TMS systems. The rest is just software, pulling in all the different bits of data and then making sense of it. And then, of course, financial institutions, payment terms, invoices passing in, passing out, so literally binary finance. Which brings up one of the technologies on slide number 22, I think it is, or 21, that I've mentioned before, and that's Bitcoin, or blockchain and Bitcoin. And that's most definitely the way this is going. Supply chain is one of the prime, industries where blockchain is going to start emerging as a forerunner, and possibly negate a lot of this stuff in financial institutions. I won't put my neck on the line, but I would probably suggest that that's where it is going, or guess that's where it's going. So you might mitigate the use and need for all of the financial entities, banks, clearing agents and so on and so forth. You might be able to cut those out of the supply chain and make it even more efficient. And then, of course, you have the government agencies. Unfortunately, now again, I am public service, so I'm not having a pop at anyone in particular, but government agencies can be laggards when it comes to technology, tend to be behind the curve a lot. Still a lot of paper-based stuff and so on, which is remarkable in this day and age. And I would even say the same of the institutes of technologies and universities. They have systems inside here. We know this stuff ourselves, or individuals across all the third level sector and so on, who have very solid industry experience, yet the cultures don't facilitate the adoption of technology as quickly as we could do. And I do joke about some of the stuff we do is quill, pen and parchment level, but look here, it's but at least the important thing is we know that that's the case, so we have to be able to adapt, and that's a point that comes up later on. So government agencies, so for example, in less cloudy, vague speak, you all do manufacturing returns, probably quarterly. You have Central Statistics Office returns, and so on. And those systems are extremely cumbersome. You have, even though they're computer based, they are still pretty antiquated. They don't allow for ease of input of information. But you can suffer penalties if you don't respond to these within a period of time. Now, there's been some leniency over the last year, obviously, because of the COVID business. But nevertheless, you can incur penalties if you don't do your returns, and if you don't submit your accounts, and if you don't so on and so on to the various agencies. And government agencies. But nevertheless, they can have and insist. Now, what's stopping them from having direct access? Technically nothing, but it's a cultural thing. What and how are they using the information? I don't want to go there. And then we provide decision-making support, so the strategic. So we talked last week or the previous lecture about aligning supply chains and partners and so on and so forth. And this is how it enables us, the long-range supply chain plans. What way do we want to develop the organisation? How do we improve our overall performances to deliver to customers? Sorry, I'm sitting in the way of some of these slides. Delivering the right products and all that, the 7 hours. So what kind of systems, how much do we want to invest in these types of technologies, if at all? If you don't, just move out of business because you really can't survive without some levels of these technologies. Tactical planning, cross-organizational linkages, supply chain activities and coordination, routine decisions, rule-based decisions. You know, what if now the rule-based are pretty standard. You know, if it doesn't follow a set sequence, then the rule is broken. Therefore, there's an anomaly. Let's go in and investigate it. We're beginning to move beyond that. That's why we look at self-learning or machine learning and AI, so they can adjust the rules and take appropriate action before even there's any human intervention. So execution and transaction processing, so the completion of fulfillment activities. Now, if we look down at the next level, we need to look at the system's capabilities themselves. So we need to have process excellence, network elements linked, and then we need to mitigate technology risks. Okay. So taking each of these, if we look at the process excellence, they identify these kind of 7 generic process excellence or objectives or goals. You know, cross-chain visibility, so the systems can talk to one another. That's what we mean. So that's how you're able to avail or buy into these control tower type systems only when you have the system open. Now, how do you open systems? It's just a software solution. If we want systems to talk to one another today, we use what's known as API, Application Protocol Interfaces. So essentially it's just in the mechanics of the software itself, it has these event management or event, in software talk, event systems or events that happen, and they can transfer data across these events. Now, an API allows you to go in and interrogate and change data inside those events, but allow from a different program, and that's how we do it. That's how, for example, app developers work with Play Store and iOS. There are set standards on defining these APIs. So anyone can write an app as long as they implement these APIs. And probably one of the first ones that came out would have been what was known as SSL, secured socket layers, which were basically protections, encryption protections, such that you could do financial transactions and so on, and that's and online payments and so on. So these are other types of APIs, so they became quite popular. So and that's how we get in to be able to see what's happening across the supply chains. Of course, agility, you know, the support analytics that help us to understand the volatility and respond appropriately. So having real-time access to information and to make decisions, or let the system make decisions for us. Velocity, that's an interesting one, because velocity essentially, it says here, adjust speeds according to situations. More realistically, it's, do you remember I mentioned in the very early days the bullwhip effect, you know, and when you don't have the information passing back to the suppliers and the supplier and so on, you end up at this huge bullwhip. The velocity effect is we can see the pace at which, or the rate at which, products or components are moving right through the complete supply chain, from raw materials through suppliers, through their suppliers for component manufacturing, to you for further manufacture and final assembly, and then on to the customer. But being able to see the speed at which this happens across all of the transactions, and that is essentially the beat of the drum. That's what we refer to in terms of the bullwhip effect. So if any one of those, there's no point in me having a faster production system, faster than the suppliers can supply to me. But if we can, so you can really only operate at the slowest heartbeat on the supply chain. So at least with the visibility of these systems, you can improve the velocity by focusing in on that slower heartbeat and give it a bit of a electroshock to invest in it to improve their operations. So you were able to do this, but more importantly, if you make a change here, you can see what else can be impacted by that change. So you're already moving on to the next, should we say, bottleneck, so to speak, to be able to improve. Overall, the supply chain is improving, and velocity across all the different elements improves. Therefore, you're potentially reducing costs and improving lead times. And then that inherently in that is you're going to have synchronization. And as he describes it here, enable strategic adaptation of the supply chain design and capabilities to evolving conditions. So things happen somewhere along the supply chain. There's a fire, there's a road accident, and so on and so forth, or a company goes out of business, is financially bankrupt or whatever, suddenly goes out of business, and you're left high and dry. Where am I going to find my other supplier or my transportation system and so on? So you can actually plan for those and mitigate those potential risks. Adaptability, segmentation. Segmentation is the one we mentioned before in terms of your customers, and segmenting your customers and matching the level of service, the delivery and order times with each of those segments. Hence you have these omni-channels. Now, you couldn't do that manually if you have any sizable organization. You would need to have systems in place to enable you, because these segments can change as well. Just because you put them into one box doesn't mean a group of customers are going to stay there. I used one example. You could have high-paying customers and high frequent users and so on, and you might say, well, they're perfect, we'll serve them and give them the platinum service. But you could have all you need is one prat in the middle of all of that, who's the biggest pain in your butt in terms of demanding, ringing up and this, that and the other thing. Get them the hell out of there and cut them out. That's the negative side of things. But generally speaking, on the more positive side of it, sometimes those customers could fall in hard times, or could be taken over by another company. Could be a merger acquisition, and they then might end up coming out of that segment and going into a different segment within your market segmentation. So that's why it's so important to have a thorough segmentation. And then, of course, when you have all of that done, you optimize. As we mentioned last week, continuous improvement. You make things better. You start going back through it again. Well, what can we do here to improve agility? How can we change velocity? How can we make things a little bit more adaptable, and so on, and do it all over again? And we're constantly. So all of these, even within themselves, are changing. And that's essentially optimizing our system. So enable considerations of trade-offs, effectively deploy resources and make decisions in optimization. So looking at the trade-offs, looking at ways of improving each of the segments. Now this is probably, to me, one of the most important diagrams around the place, because all of this stuff is wholly dependent on and underpinned by these three elements down here. And of course, people are centric in all of this. So whatever you're trying to do with your technology, you have to have it integrated into people and processes that already exist in your organization. What does that mean? It may mean, well, how it's done, first of all, is training, upskilling, all that sort of stuff. But also means changing some of the process. So you're looking at new systems. You're looking at, let's just say tomorrow morning you say, well, okay, we're going to apply or outsource or partner with some control tower company that's providing transactional control tower platform, cloud-based and so on. Where do we even start? You need to start back here. What do we need in terms of the skill sets? How is it going to affect people's jobs as they are? How can it improve the way people are going to perform themselves? And of course, what processes? Do we need these existing processes? Do we scrap them? Are some of them already just manual that we don't need them? And so on. So that's on a simple level. But your starting point will always have to be down here. Don't be, blinded by the shiny baubles of technology all the time. Because unless you're able to stand back and look at what and how you're going to develop these technologies, then they will become what's known as shelfware. They'll just become, and they won't get used. A lot of companies buy stuff in, and I know for a fact that SAP is in many medium-sized business, small to medium-sized businesses. Those companies only scratch the surface of the likes of SAP's capabilities in many instances. Why? Because the fear of how complex this can look. And I would be the first to put my hand up and say, yes, SAP is a complex system. But you don't need to know the nuts and bolts of the SAP system. You don't need to be a programmer to know the nuts and bolts of this system. Suffice to know there are modules like this diagram here. There are modules like this. They interact. So if you have a finance module over here, you know it interacts with the operations modules. It operates with a customer relationship management system. It'll operate, which in turn has several elements of marketing inside there. And and if you're just someone purely working on marketing collateral, that's a cost to the company, and it's an administrative cost to the company. But you know that this plays into the bigger picture. That's how we need to enable employees to understand where these things and how these things fit together. Risk. Unrealistic assumption that the supply chain technology will readily solve, which I kind of mentioned already. You might bring it in, and you might look at technology. Oh, this is going to solve our warehousing. But what other problems could it cause for you? So not looking at the bigger picture is often the biggest mistake in terms of risk. Thinking it's going to solve a problem. And I will always advise people when putting software in, or any kind of a solution or a process in place, to unlearn what you already learned and relearn to do things differently. And that's important, because in the earlier days when we started implementing software solutions into companies and into finance and so on, and operations and that, we were trying to get them to develop the systems, the technology and the software to do what we were already doing. And straight away that was an open checkbook for the providers. Simply because, that's a bespoke, that's a new requirement, that's this, that, and the other thing, and so on and so forth. Instead of unlearning and learning what the new capabilities can do for us. But there lies a problem. No one generally has all the knowledge in the company to be able to know all of the benefits, or how it can benefit a particular company. And I'll come back to this now in a short while. Weak technology process alignment, leading to ill-fitting solutions that fail to achieve, which I just alluded to. Technology gaps as a result of piecemeal purchases, developing systems over years, having an off-the-shelf piece that does one piece of your warehousing, and another piece that does a little bit of a conveyor belt, and it tracks data in through optics, for example. And one system uses barcodes, and another system uses RFID, and so on. So you have all these piecemeal type things. So you end up with a patchwork quilt of systems inside your organization as your organization grows. And that's the kind of thing we're alluding to here. That when the initial investments or the initial decisions to implement some kind of a technology was being made, not enough thought and effort was put into the decision-making process. And something that I don't teach you guys, but I do teach in other modules, is project management. And that's what it comes down to, is proper project management. And 80% of projects fail fail as a consequence of the planning phase of the projects. 80%. And God knows, over the years before it came into this existence, we did all of this analysis, and then it took another 5 or 6 years before the academic books started to support what we were saying. Why? Because they found our research, and they started to look at the research that we had, the data that we had, and said, and they write books about it. But it's still, unfortunately, the case that failure mostly goes back to the planning phase. That's why I say a good project manager is worth his or her weight in gold. Okay. Moving on then, we talk about challenges in cross-chain supply integration with suppliers, providers and customers. Again, that comes back to the types of systems that you have in-house and you're trying to talk to another systems. This EDI or APIs, whatever technology. The most common one that we use today is XML, which is your web-based, internet-based language. HTML sitting on top of this and XTML or XML. It's pretty straightforward language. A lot of code is built on using XML. It's easy to use. If you're when you're finished of this course and you're bored, one course I would suggest you could take is it's about 6 months long. I don't know how much it costs, but the Coding Institute above up in Dublin, or the Code Institute, they do a fantastic program that takes you from no knowledge on computing right through to be able to write and design and develop pretty damn good web pages and so on. Now you might say, oh, it's only web design. Absolutely not. It teaches you all about HTML and XML in the background and so on. It's a challenging enough course, not too onerous, but if you wanted to come up to speed in technology and create opportunities for yourselves in your respective roles today, I would recommend that. And I'm not being paid to advertise or anything of the sort. It's okay. And as I said, poor planning on for technology and implementation. That should be up there at the very start in terms of risk, not down at the bottom. Moving on, so supply chain. Well, we'll just fly through some of these. Essentially, these are the types of systems. These are just what a block diagram. So you have enterprise resource planning systems. What would have started out as materials requirement planning, in the 80s, now are enterprise resource planning system. In other words, cover the whole organization. So not just about controlling stock and running production runs, which it used to. That's where it all started. Right through to integrating HR functionality into finance, marketing, and so on. Obviously, enterprise-wide. Then you have customer relationship management, which oftentimes these are just are the bolt-ons to the enterprise system, but these can interact with other retailers, for instance, distribution centers, but also directly to your end client in terms of capturing transactions and data about your market and your customers. Events management. The event management would cover your transportation management systems, for example. The logistics side of this would be more in supply chain execution. That's more internally focused, looking at operations. Here you have the logistics side of it, and implicit in that is transportation management system. So automatic identification tools, which kind of comes under the business intelligence as well, but essentially, again, these would be systems that can pull barcode, RFID, what are the other ones? All sorts of electronic tagging type systems. Before you used to have forklifts with RFID readers on them and so on. You don't need that anymore because now they can be Wi-Fi or Bluetooth transmitted, so you don't need that level of interaction with them because it's done seamlessly. But these kind of business intelligence systems, some of them. Do you remember I mentioned the example of corrupt data on because of the electromagnetic interference from an electric motor on a warehouse door opening, and it was corrupting the RFID tags of products close to it. And one company spotted all of this because there was a dump file, something like if you have a system crash on your PC, every so often it creates these log files. The same type of idea, except for these dump files that have spurious characters and things inside it. But nevertheless, to trap all of these on such a date, this was dumped and blah, blah, blah. So they were able to extrapolate from that and reconstitute the information. so to match the physical products that were in the warehouses, for example. So it was a very clever piece of equipment. So they brought it down to almost zero through a piece of software, the tags being corrupt as such. And of course then you have supplier relationship management software as such. Again, the business intelligence element of that and supply chain planning is transferring data, leaving your suppliers have access to your systems to see what levels of stock you have, so that they can keep the right levels coming at the right pace into your system. Where are we doing? We're not doing too bad. So the planning application, or applications. So supply chain planning applications help organizations shift from autonomous planning activities to synchronized. And all that means is that the individual elements or the individual components of the supply chain, your company, your supplier or suppliers, their suppliers and so on, and your wholesalers, distribution, wholesalers and retailers, those individual components are now synchronized as opposed to being simply autonomous. Why? Because we've allowed visibility, we've allowed connectivity between all of the different systems. So available and capable to promise, in other words, that your system can deliver on the expectations that you have. So again, this is why you have to be extremely careful in the planning phase of implementing any of these technologies, that you have clear sets of requirements, that you know what you want to do. And oftentimes you have an idea, it might appear that everything is clear to you or to your organization, but then there's a realization that, hang on, this stuff can actually do more for us, and could we use that? Could we use these features? Could we use this functionality and so on? How could it benefit us? And that's where it becomes a little bit of a problem. Now I'll stop on that point and come back to it in a while, but keep it in mind. So data collaboration across departments, suppliers and customers. So collaborative planning and forecasting, because we're passing the data back, that underpins efficiencies and cost savings. You know, supply planning, inventory planning, all of this planning, because the systems are working as an integrated or single entity. Therefore, you can fine tune and save money. That's, the end goal. Service customers and save money. Production, multi-plant capacity and so on, inventory strategy, optimization. So these are all the different types of elements that we need to consider. Vendor management, inventory, direct point of sales, in terms of the what do we want to do? It's like a shopping list of modules and stuff that we want to be able to do. And you'll probably say, well, we'll tick the box on everything. Fine. If that's the case. But sometimes, you don't need, what's the expression? You don't need a sledgehammer to push in a thumbtack. But if we look at some of these other, the execution applications, previous ones were planning application, the planning softwares that we need. So we want to have something for demand scheduling and all this sort of stuff. Now we look at the actual execution: warehouse management systems, order management systems, distributed orders, transportation systems, global trade management, and then of course manufacturing execution. So work in process management. So how can we extract, and the kind of work in process management could be anything that's trapping data, scanners that are picking up on a product that's been assembled over several production processes, for example. So you can actually read at which point. The great example of that was the BMW's Mini manufacturing in Cowley plant, and how they actually scan those, or Kawasaki's building their Ninja bike, fantastic bike, motorbike, let me hasten to add. Not my kind of bike. See, I knew I'd get a mention of it sooner or later here tonight. But in any case, they have these fantastic scanning systems, and they know precisely what components have to be put into the different variants of the product. So whether it is I don't know, whatever it is, 1100, 1200, or 1300 cc motorbike, they have different harnesses based on the configurations and all that. So the system is even human proof. So only the right drawer opens with the correct harness that's already provided to the production line through their integrated system. So even the torque wrenches and screwdrivers that the operatives use to in the assembly process, they're pre-configured and adjusted to the level that each of the components require. So again, reducing human error, improving quality, and all of these are timed. One of the examples I've seen of that, and it just shows how the level of detail that these organizations go into. A few years ago on one of these trips over to, it was actually over to Mercedes, but it wasn't a Mercedes, that was one of the half-day trips while I was there. I was going over to one of these Fraunhofer institutes, which are like the IoTs in Germany. So you have the Max Planck universities, which are deep research. I was going to say like the Trinities and UCDs and DCUs, but they're not like that anymore. They're into everything and anything. But the Max Planck would be pure research. And then on top of that, you have the applied sciences, and these are the institutes of technology equivalents. And then you have the trades and so on. And trades are big in Germany, and they're held with extremely high regard. In these Fraunhofer Institute, there was one building that was designed by the students, staff, and the customers. The customers being some of the local industries. There was graphic design, this, that, and the other thing. Apart from all that stuff, there was one particular, I call it room or suite of rooms and so on, and there were like mini production processes. And in one particular process, there were benches with overhead screwdrivers that were using to assembly for part assembly on printed circuit boards and these were for parts in Mercedes factory, which was just down the road. And the problem they had was the shift workers, and they wanted to develop a workstation that was so versatile for. And again, I'm not into gender stuff, but they had small women and tall women working on these production processes, and they wanted a system that could adjust the strength of the screwdriver as it was being pulled down without having to leave the seat. So a smaller lady would have had to get out of her seat, stand on the rungs of the chair to get up and pull it down, whereas a tall lady could just reach up and pull down. That's the level of that was so typical of Germans and their attention to detail. Let's look at all these different, and then of course there was other types of situations where if you wanted to use to print logos and all that sort of stuff, they brought you in. Here's the software. Here are the blanks for your USBs, and now we can print your company logo. Design the print. So they showed the process of how all this was done. So it was a perfect example of how these systems can actually be demonstrated, and for people to understand what they're getting themselves into when we're talking about these systems. I've gone slightly off tangent here.
But a lot of the problem with those systems can be the validation of those systems as well. Like, it's not just the technology is the great part; it's the validation and bringing it into the process is the hardest bit.
Exactly, and that's the key point from what we were mentioning earlier on: the processes, people, and the technology. So how do these technologies either integrate, replace, or totally overtake existing processes? But you have to start with what you already have. And I'm coming to it a little bit earlier than I wanted to, but might as well clarify it now. You must include the people that are operating the processes in these decisions as well. It isn't, as senior managers, nice to have bauble collection of technologies. Not to be disingenuous to any senior managers, but unfortunately that can be the case. you need cross-functional teams. You need the people. I'm telling you, I'll bring it to my grave. But if you want to make a change to a process, ask the people that are currently using the processes. Ask for their input. Ask how they can, what changes would they recommend. Do not go down with the manual and say, there you are, do what's in this manual. If you did it to me, I'd throw the manual at you, put it as simply as that. Or you better duck, because there'll be a 4x2 swinging around the place. Because people have tacit knowledge of the processes that they're actually operating. They've built up experience, knowledge, and improvements on the process without breaking the process. So they become more efficient. You're trying to trap that, not the actual process itself, but tap into that tacit knowledge. That's why I say involve the people. For crying out loud, it sounds so simple, but unfortunately, culture's arrogance, call it what you will, precludes that simple process in many organizations, and you're losing out on valuable improvements, valuable efficiencies. I mentioned it before. This is my third time to mention it. Carol O'Dell, if we only knew what they already know. And that's precisely what we're driving at here in terms of the processes. And as you're saying there, Paul, integrating. So these technologies have to be seen. So someone with the knowledge of the processes, where it's thought or expected that the process would be affected by some new piece of software or piece of technology or whatever, involve them and say, right, this is, what do you think? How will this work? Can we modify our process? Will this piece of software make what you're doing more efficient? And can you then upskill to use this, and so on, so on, so on. That's the pragmatic way of approaching these problems.
Couldn't agree more.
Hmm?
I couldn't agree more. It's exactly the way you should be approaching it.
Yeah.
Have everyone involved at the start with a kick-off meeting.
Absolutely. Cross-functional teams, I swear by them, and involving the people. More importantly, it's a fundamental motivator. You get the buy-in. Literally everything is plain sailing. You should see when you get the formula right, you should watch people's reactions and just look at the level of buy-in and their demeanor, their facial expressions, and so on and so forth, because they're involved and they're highly motivated. And you just, as the team lead or the manager or whomever, you just stand back and just watch it take life on its own. And if you're fortunate enough to have worked or are working in that type of situation, I envy you. I said, I was fortunate to have been in that type of situation, in 98 to 2004, 2005. Never saw it before, well, to a far lesser extent, and I definitely haven't seen it since, and I won't now at this stage. But involve the people. So event management tools, I would say here, provides cross-chain visibility of conditions before snowball into it. So this is more into the transactional control tower type systems. So you can see what's going to happen. You can take corrective actions based on what's happening in this, and it could be a simple thing. That Cowley example is very good when they're talking about their transportation management system and their suppliers supplying into them. And when they come to Dover, when there's any kind of issues on the French side with their lorries, they're ready to use helicopters to get the components up to, where is it, Coventry or whatever it is, for their production. Anything it takes to keep the show on the road. Why? Because the trade-off, it would cost them millions to close down or stop. Hit the big red button. The Father Ted and Dougal on the plane, don't touch the big red button. Well, they do actually have a big red button in that production plant in case of an emergency. And even when James May was in there interviewing the people, they were extremely nervous that he might just jokingly hit it or so on and so forth. They were anyway. That's the whole point about it. The show must be kept going at all reasonable costs, but that included helicopters, but on a more basic level and so on, they're able to identify any potential traffic jams, roadworks that you can't see happening. You know yourselves. Anytime you use SatNav, there's always some kind of roadworks going on, and you're going to have to change. So it changes for you. It'll replan a route and so on, because you're seeing it, you're interacting. You take it. Oh, I can't go down. I can't take this right hand turn. I better keep going and take the next because of the road diversion or those roadworks. They weren't here yesterday, but they were here this morning. So your system will adapt to it. But you've done the intervention by not following the sat nav. You've gone on to the next one, and bang, it recalibrates. So that's the interaction by you just ignoring that, and it has to recalibrate. That's the type of system we're talking about in terms of supply chain itself. So built-in workflow rules initiate automated responses. Again, this is where we begin to come down to some of the, how would you say, the intelligence within the systems themselves. Integrated into other applications, event management solutions help to close the loop between planning and execution to support synchronization of end-to-end activities. So when you have all these systems talking to one another, and your suppliers might be using one transportation management third-party service provider into you, and you might be using a different one. Probability is might be higher. There might be a different type of transportation system, but these two systems are talking to another, can talk to one another. Excuse me. Where am I going here? How are we doing time wise? We'll keep going because we'll be finished within a half an hour, give or take. The business intelligence opportunity areas, so self-service, reporting, data collection, and big data analytics. Just don't be frightened by that bullshit of big data. I know my colleagues' side might be find me a little bit disingenuous when I say things like that. They are just freaking concepts. They're buzzwords, they're fads and so on and so forth, but they're fads that are going to last for quite a while. Big data just means there's a hell of a lot of the ones and zeros around now than there was 5 days ago, 5 years ago. It's just the way we're able to layer it and layer it and layer it and use systems to make sense of them for us mere mortals to use. And that's why, because we can talk to all these different systems now, because we have the transport capacity, and by that I mean internet, broadband, the 5Gs. Now the systems can interrogate something. You can interrogate the Dublin city traffic core data, whatever it is, to find out what's happening in the city in advance of taking the trip up there, for example. But the systems do talk to one another. That's what we talk about big data. All the stuff we collect through our mobile apps when we walk down, and for example, you go into a shop and you probably get a message or an email or a notification. Tell us about your experience in such and such a shop. Fill in all the data. Gathering data. That's all this big data is. Just different ways of getting information or getting data back to try and make some kind of sense of it. Graphical dashboards, and that's how us humans, because as I said, the ones and zeros don't make a lot of sense, and nor do many of the outputs. So we have to translate it. Now we're getting into they call them these graphical dashboards. I mean, it's like your speedometer and so on and so forth. But we're already in the realms of virtual reality, where you can actually see all this stuff in 3D. Sounds futuristic, but it's already there. When was it? It was 2009, I think it was 2010. Drogheda, or Dundalk Institute of Technology, they had a room up there for VR, and it was literally like going onto the holodeck in Star Trek. Literally, the black with the yellow lines on it. And they put, two of us went in there and they stuck these headsets on us, and they told us we just put this together overnight, knowing that you were coming up to visit us, and it was like walking down costume barracks along there by the army barracks in Athlone, and you could turn around and you're looking down the river, across the river, and all this sort of stuff. Now you have that, and now what they were building it for was assisted living. This was 12 freaking years ago. And they had these mock-ups of a room in a bungalow type environment. There were 6 bungalows together. They were censored up to the hilt. Windows, doors, fridges, everything you could think of inside, switches, everything was censored for visually impaired or blind people. And you use these headsets, so they were able to plan the routes and where furniture, the height of furniture, the distance the furniture was apart, and so on, so people could familiarize with themselves. But the data they were gathering was phenomenal. It was like, do you know these tachographs from your lorries? They're like circular 24 hours of data when the lorry was moving and this, that, and the other thing. Well, they had that type of data, except for in one instance, when they're collecting the data, they spotted something out of sync. So normally when you get up in the mornings, the heating was coming on, this, that, and the other, doors were opening, locks, and blah, blah, blah. So they could track all of this sort of stuff, and they spotted some anomalies. And what they found was on one particular inhabitant was going out at unusual times of the day and night. And through that, they looked at his behaviour and his patterns and so on. They were able to determine that he was suffering from depression. And that was how these behaviours manifested themselves, and so on and so forth. So that's the kind of thing in terms of big data, collecting all of this sensory information and how you can use it, and graphical dashboards. Now we're into the VR type things and interactive holographic type stuff to be able to develop and change processes without even doing it. Where did I see it lately? You've heard me mention about Six Sigma, and the highest level of Six Sigma. You're using data and analytics and statistics and probability to make changes to processes before you actually physically make the changes to process, so as you can mitigate risk and identify any issues and then reduce it. But there was something more recently came up then on that kind of train of thought. It had to do with virtual reality and process improvement. Anyway, activity monitoring, supporting event management, and of course access to data residing on multiple supply chain information systems. That's what the acronym there. So resolving logistics bottlenecks. That's what I mentioned earlier on, where you have the systems talking to another, getting a constant beat of the heart, all the hearts beating at the same rate across the supply chain. And it's only when these systems are talking that you can actually see which one is slightly ahead or slightly behind, and the consequence. Because if it's slightly ahead, they're producing more, which means it's going into a warehouse, it's going into storage, which means all the additional costs. So you can remove that. If you can get the other ones to beat at the same rate, then you have the flow, and you reduce all those unnecessary costs as such. Facilitating tools, so enterprise resource planning, we have supplier relationship and customer relationship, and then the automatic identifications, the likes of auto ID and data capture technologies, that you have RFIDs, barcode scanners, and all that sort of stuff. And then implementation. Now this is a way I could talk about this, and I've already mentioned it, is through project management. Paul has also mentioned it there in terms of involving people and so on and so forth. And as I said, having the right people involved on the project. And that means in most cases nowadays, if you want to implement a new SAP system and so on and so forth, you'll have your own internal possibly IT guys, or you have it outsourced to another company. They may not be the ones that are implementing the new system, but you better be damn sure that you include them, because they're the people in your organization, even though it might be outsourced, who are going to be impacted by these new processes. They've already gotten the existing processes, the way you're backing up stuff, using data, and so on and so on. So they need to be involved in a decision to implement new software, for example. So getting the cross-functional team is extremely important, and take a project methodology, a project approach. Clearly define the requirements. Then what do we need to future-proof it? How big do we think we're going to get? How much do we know about where we are today, and where do we think we will be according to our strategies and so on in the next 3-5 years' time? Therefore, we need to buy a system that keeps us, that will support our system for the next 3 to 5 years' time, because you don't know how fast you're going to grow or not, and so on. So you don't want to be going back and getting additional licenses. Maybe that'd be a simple solution, but having to upgrade your system and go to the next level and the next level and so on, and be overwhelmed with all of these system upgrades, because you try to save a few pounds here and there by going for an entry level system. The Microsoft CRM is a very, very powerful system or package, and I know that some universities use this extremely efficiently and exceptionally well, and then there are other ITs and universities that just have the off-the-shelf, and the wrong people have been trained on it, and it's sitting there. What a waste of freaking money, you know. And I said, Jesus, give me access to it. I can play around with that, and I could use it with my students, for heaven's sake, you know. Oh no, you have to go through 10 layers of freaking 14 tenders for this and 15 approval forms for that. So the software selection itself, you know, choosing the rest. And again, do you want? Are you only trying to solve one simple problem? And you say, yeah, that's great. This piece of software will solve my transportation management system. But does it work with your existing systems? What else could it affect, positively or negatively? But do we need to upgrade our ERP system to work with a TMS system and so on? So these are and selecting them is extremely important. Now, most of the time, it's an easy selection. Certainly in supply chain and operations, the overwhelming leader is SAP by something like, I think it's 90% of world sales, or at least 80%. I think it's 90% of world sales are in ERP systems is SAP, or for the die-hard purists, SAP, freaking SAP. So mitigate implementation issues, again, involving the people in your organizations that know the process, because I can guarantee you won't know it all, and you need to make sure that you've, or at least be somewhere confident that you've covered all the possibilities and reduced risks. I did talk about Cuisine de France and their rollout of upgrading of their system, and didn't involve the people, and their own IT people had to come in over a weekend and solve the problem. And but the knock-on effects were just horrendous at the time. It's Portland that tells you. We talked about it last week. And then, of course, the 10 golden rules for implementing secure commitment from senior staff. Remember that it's not just about information technology project, it's the people and the processes that's who are being impacted. Align the project with the business goals. So unless you have a clearly defined strategy and clearly defined strategic objectives, where you want to align your supply chains with whom, then you don't know, you're literally flapping in the wind if you don't have clear goals that you want to try and achieve. Get the software to work for you, not you to work for the software. Understand the software capabilities and dynamics, and that may mean obviously having someone that's I'll say software or computer literate, but not someone that knows how to turn on and they can run this application, but they have the wherewithal to know that where could this technology be going. Are we backing the right technology? What are the future trends in these particular types of technologies, and then decide on. Now, because if you ask the vendors, they'll tell you anything. You know, God love them. I mean, they're there to sell this stuff to you. But you need to have the right people asking the right questions, in terms of the capabilities. Know what your objectives are, and then to be able to put these objectives to the vendors, software vendors, and selecting the partners carefully, which is implicit from my point earlier on there. Then follow proven implementation methodology. The implementation methodology, once you've sorted out all your requirements here from this side of stuff. If I wanted to go on a different route on this, we have what's known as, I don't know, some of you might have already used this methodology, but the business model canvas. And and it's a very powerful little methodology. 9 boxes. Who are your customers? What are you trying to sell to the customers? And then who are all your partners and all that sort of stuff. And that's before you build anything. You go through numbers of iterations, questioning scenarios and all this sort of stuff to finally fine-tune what your offering is going to be. Well, in this case, it's like using the business model canvas. Geez, I'm just after thinking of something. As a precursor to your project management, but inverting it. You're not developing a product, you're bringing something into a company rather than sending something out of the company. Jesus. At least it's recorded, so I do have ownership on the idea. But that's before you start to go and implement. So there's a lot of work in the pre-planning phase of any project. That's the point I'm really trying to come to, before you start to implement anything. And the implementation is through a clearly defined methodological approach, project management approach. And ignore all of this stuff around synchronous and asynchronous and this, that, and the other types of methodologies. They are all simply waterfall models. You do X, you do certain, you do Y, and then you do Z. Sometimes you'll be able to overlap bits and pieces, but they will all step. That's the critical path. No matter what kind of packaging and wrapping around and variants are out there, strip them all away, tear the onion back, you'll come back to that simple understanding of project management, of a waterfall approach. The rest is just, as I say, variants of the same theme. Take a step-by-step approach, incremental value gains. I mean, this is so powerful, these points. You need certain successes, as Paul mentioned earlier on. About the people, involving the people, and you get the motivation going. You need small success stories. You don't have the big bang approach, which I mentioned in the previous lecture. You take it in a phased approach. That's how we've always done it successfully. Other places didn't. People got burned. And some of you may have already been involved in the project. I don't know, it doesn't particularly matter, but it's a great exemplar of how not to do things. And that was the PPARS project in the HSE. Some of you are probably in there, I don't know, don't take offense. I've used this since the freaking thing came out. But there was no project management. The different health boards as they existed back then, they all jumped on. One said, oh, you're doing it, I like to do it. The only thing I can't remember was a Price Waterhouse or KPMG were the consultants in there, and at €1,500 a day to €2,000 a day per person on site, they didn't care. Well, oh yeah, we'll do that for you. Oh yeah, we'll do that for you. Oh, you want to include these? It was only supposed to have certain salary scales or pay rates involved in this PPAR, and each and all of them started to jump. In other words, the scope creep, a project management terminology, just got totally out of control. And it was now, in some places they're still using or trying to use bits and pieces of why. That's an ego thing, nothing more. People put their reputation on this. We'll get this. We'll make it work. They didn't. They're using bits and pieces of it. It's just one perfect example of an unmitigated disaster in project management terms, at least. And and say nothing for what are these other things we had there? The voting machines. Help me. So keep end users informed and involved, people, and measure success with the KPIs. So you actually have to have deliverables, the outputs from the project itself, targets, milestones, toll gates, and what are we trying to achieve, and show the success of what's happening gradually. Supply chain technology innovations, the last step. I've mentioned this before, Internet of Things, the great savior. Well, it'll be one of them. It's just going to provide an awful lot more data, switches, linkages, allowing intelligent connection of people, processes, data, and equipment. It could be, if you want to look at the Star Trek approach, or it could be you're sitting at home using a VR system to run your production process in a production plant at the far side of the world, but you're doing it in real time. Your work is being done virtually, and it's been implemented either through machine technology at the other side of the world or whatever. but nevertheless, unless the systems are getting there, they're rolling out as we speak. Mobile connectivity, this is one of the more interesting ones of recently. You know, the likes of using your tablets and mobile phones and so on as portable, so you're not chained to your desk to have to use the systems. The systems are so flexible. As I said, mobile phones, visibility, asset control, agility of supply and demand. You know, even a simple thing like having apps on your sales reps, so they can actually see the levels of stock and they can actually make decisions there and then on discounts, availability, and lead times to the customers while they're talking to the customer, without saying, "I'll take your order now and I'll get back to you on that." All that sort of stuff. The old way of doing things. It's done in real time. That's essentially what we're talking about here in terms of mobile connectivity. And one of the other elements of the futuristic Daimler's 2025 program or project is for lorries, autonomous lorries on the roads. However, they're not fully autonomous. You'll still have a driver, but the lorries talk to one another. Literally, the lorries talk to one another. They're connected using sensors in the road and all this sort of stuff. So, for all intents and purposes, they've taken the flight airplane concept, the autopilot. When did they use the pilots, the human pilots? Takeoff and landing. Well, the same thing for these lorries. When lorries are in around complex cities and so on and so forth, where risk is higher, they hand over to the human driver. But out on the main road, then they can move at the pace that fits the velocity of the supply chain. That's the point they're coming to. But these can be more efficient. Why? Reduce costs and fuel, saves money. Keeps the lead time, keeps the velocity going at the right pace, saves money, and so on, so on. And then, of course, functional automation. Long been part of manufacturing, so warehouse automation has gained tremendous traction lately, and then connective technologies needed to support driverless vehicles. Well, that's it there again, functional systems. Is there anything else? Oh yeah, this is one of the add-ons. This is just a list of the 24 best known technologies that are evolving and that are future and evolving. Well, we all know about cloud computing. I mentioned blockchain down here. Big data is already there. 3D printing has been around. Wireless communication has been there. Sensor networks, pretty much there. Robotics has been around for quite a number of years, but they're becoming more and more intelligent. Real-time process control and so on. What we flexible manufacturing systems. Databases are now cloud-based for the most part. Environmental control systems feeding back, and so you have and what in terms of these systems, what can that do for you? It can actually support your green agenda and sustainability and so on through track and trace and more efficient use of your power resources, whether it is electricity, gas, or whatever, oil, and so on your systems. And pretty much there, folks. This is the last slide. How are we doing time? As I told you, I would not be keeping you until 9:30 or 10 o'clock tonight. That's just... Who made that big sigh of relief there? I didn't catch that. That's essentially it. That is it. Fortunately, as you would say. Do we have any... Come back to me? Yeah. Before you go to your extended coffee break, any
football
questions?
on. It's football on.
Is there football in? Is there? Oh, very good. I'm going down to watch the recorded cycle race today. Of course, I'd have to get that one in, wouldn't I? Anyway, listen, folks. I won't hold you. You have enough to keep you going there. We have only one more. I
Hey,
might.
Mark.
Yeah.
Can you talk a bit about the assignment?
No. I can, but not a lot. What would you like to know?
No, on Saturday you were saying about some people starting too early, and I just didn't hear what the reason was.
Did you look at the video?
No, I was at it, but I didn't rewatch it.
Okay. No, because there was information on Saturday's presentation that would have been pertinent to your assignment,
Oh, okay.
and it's just some people had started, and it's yeah, that
And
was really.
if you don't pick one that's on the list, do you have to give a reason why or anything?
No, no, oh God, no, they're just kind of guidance examples. The real message I was sending out there on that list was go for big companies or relatively large companies because you'll have easier access to data on the
Yeah,
companies.
yeah.
And that's the only reason I picked those large companies. I mean, you wouldn't pick your local small manufacturing company because the data wouldn't be there unless you're privileged to get in and they'll give it to you, which is unlikely. But
Yeah.
mostly large companies, there'll be so many papers written about them, their annual reports. Not that you need much out of that anyway, but there will be so much material available about large companies. I mean, I just for example, there, I talked about Daimler and their truck technology. So there's been dozens of white papers about them already. Um, that's
Perfect. Thanks.
and um, the one thing to watch out for would be, as I said, you're looking at one primary company, and I did say that at the outset, it's always easier to deal with a product manufacturing company than a pure service company. But there are things about service companies that product companies could learn and benefit from. And that's the point. Previously, when I used to give this assignment, say you pick one company from product and one from service, analyze their supply chains, and then make recommendations, one for the other. So, and I said, right now I'll simplify that a bit more and say, pick one company, one or the other, and then, but you still need to look at the. So, for example, if you're looking at a product company, you analyze their supply chain or elements of their supply chain. Then you might look at a service company and just without going through all the same level of research that you would have done for the product company, you just look down and say, well, what are they? They're doing something different here. Maybe the way they're managing their customers, maybe the way they're transporting the service might be Amazon or eBay. They're doing certain things here in their delivery system or whatever that the manufacturing company could borrow from and benefit from, and they're the recommendations you'd make back into your product company. I tried to use that example of the smart car, how they thought totally outside the box and say, well, rather than being just a traditional car manufacturer, let's look at it differently. What could we do, and how could we do it differently? Even their showroom approach was to build a tower which was automated, and you chose the car and said this one machine went up, picked it up, brought it down, and all that sort of stuff. Was that new? No, they borrowed the idea from some of the car parking facilities in Tokyo.
And if you talk about, say, COVID and the pandemic, is it okay to kind of say how this could happen again? Like the WHO have said there will be more things like this, so that they need to plan for another pandemic.
You're asking the wrong person about that because I have I'm very opinionated when it comes to all of this. Um, um, 2 years ago, it was all about Brexit. That's been an unmitigated disaster, and companies are suffering left, right, and centre. There were obvious solutions. One of the recommendations that you could make, both in relation to COVID and Brexit, get rid of all politicians. They're just interference. That's all. I mean, if you want me,
Yeah.
my absolute crude, my opinion, not the college's opinion, but if you really want to mess up commerce and economics, involve the politicians. Now we have the health industry involved, and again, looking at one facet of illness, and there's a whole range of other stuff not being looked at. Should we worry about this when that happens? And as it's already been pointed out, even that guy, the Irish guy O'Reilly in the WHO, he said that total lockdowns, the way this has all been handled and so on and so forth, will be paying for years in with the impact on mental health.
Yeah,
And
yeah.
that's just the tip of the
Like
iceberg.
there's other facets of health to
Yeah.
even look at.
Yeah. So there's always a threat of these things. So what have companies learned from it, and how could they mitigate the interference and all of this sort of stuff? Again, I don't have the answers to that one, but yeah. What would I? No, I don't actually have the answers to it. It's
How detailed do you kind of want solutions or like improvements that they could make their supply chain?
could you repeat
It's
that
only
again, please?
like improvements to their supply chain, whoever you're using. It's literally only your opinion, isn't it?
It is. Well, it's
Yeah.
based on now. A good question actually. Now, whatever recommendations you make, or improvements or suggestions, they have to be grounded in your SWOT
Okay.
and the weaknesses. So in other words, that there's a logical approach. In other words, you've taken the strategic management approach. You've gone down through the various layers of it on the supply chain, and based on this logical process, you've identified certain weaknesses and certain strengths, and this is what I recommend we do. And as I said, only a handful.
If you don't have a solution or a recommendation, could you say just to research more into that weakness?
Uh, no, because you would be identifying. Your SWOT is going to throw up something, for sure.
No, I know, but if it throws up a weakness, but you can't find a solution to it,
Um,
or
well,
research to do it.
that's the whole point of a recommendation. You know, how would you go about?
Yeah.
And this again, going back to my point from the last lecture, when you identify such weaknesses or strengths, be careful that they should be actionable, that they are something that are essentially doable. I mean, you know, if there's no point in making a recommendation. Our weakness is we don't have enough money, and the recommendation would be that if we had all the money in the world. I mean, that's too kind of obvious as such, you know.
Okay.
But something that's reasonably actionable, you know, and you know, it could be, for instance, an upgrade or some innovative technology could be a solution, for example. It could be a simple case of partnering with the right 3PL, 4PLs, or collaborative partnerships. These are doable. But if you're trying to take over all the suppliers to guarantee your supply chain and have a smooth supply chain, it's not doable. You wouldn't have the money to be able to buy all your suppliers and so on, or buy all your outlets, for example,
Yeah.
particularly when you're taking one of these large companies. You know. So,
Okay.
you know, taking the two, you know, my idiotic end conclusion would be if you were BMW and you wanted to guarantee that you would always have the tires for your cars, that you bought up every rubber tree plant and synthetic rubber manufacturing company in the world, just so as you can guarantee your supply to grow your market share, just wouldn't be possible. You know, you wouldn't have enough money to do it. You know,
Yeah, thanks.
not at all. Okay, everybody happy?
Mark,
Boys?
just one logistical question. What's the word count for assignment two?
From memory, it's in around the 3,500, 4,000 or something like that. From memory. It should
Okay.
be-
3,000.
How
It is
much?
3,500.
3,000 to
on the front
3,500.
page. Yeah.
I'll accept up to 4,000.
Thank you.
I should have actually made this 5,000. You know that.
You're
So-
all right.
Juliet.
Some people say to me, "Jesus, can you? Because I can't cut back."
Or can I just ask, when you say about theoretical concepts, they're the likes of value chain and as well as the SWOT, is it?
Yeah.
No, I'm just thinking of doing the analysis of the company with the value chain.
Yeah, that's pretty much on the button. Yeah.
Yeah, okay.
Okie dokie, folks. What time is it? 8:30. Jesus, that's perfect. I could start this. No, I won't.
Enjoy your restart.
Okay, folks, I'll let you go then.
Thanks, Mark.
Okay, cheerio.
Cheers,
Take care,
Mark.
see you.
Cheers.
See you. Good night.
Bye bye.
Thanks,
Bye bye.
Thanks a
Thanks,
million.
Mark.
Thank you.
Okay, good night.
Good night.